Hello students, I'm going to proceed on the derivation of the Fourier coefficients. Last time we derived the coefficient an to be 1 over L from negative L to L f of x cos of n pi x over L dx. So we are going to proceed with finding Bn, but we have to recall the Fourier series formula, which is f of x equals to an over 2 plus summation as n runs from 1 to infinity an cos n pi x over L plus bn sin n pi x over L. So that is our equation 1. So step 1 is we are going to multiply equation 1 by sin n pi x over L. Then we integrate from negative L to L. So that is what we are going to do, and we immediately follow the step 1. That is, we multiply by sin n pi x over L, then integrate from negative L to L. So this becomes from negative L to L f of x sin n pi x over L dx, which is equals to a naught over 2 integral from negative L to L sin n pi x over L dx plus summation as n runs from 1 to infinity of what? N runs from 1 to infinity of an integral from negative L to L over cos n pi x over L times sin n pi x over L with respect to x, and then plus bn integral from negative L to L sin n pi x over L times sin n pi x over L with respect to x. So we now recall the properties of odd and even functions. Like as you can see here, sine is an odd function. And what is the property of an odd function? The property of an odd function is that if you integrate under closed limits, the integral is always equal to 0. So this one drops down to 0. So, and this one is an even function, and this one is an odd function. Even times odd function, you get what? You get an odd function. And like I've said, if you integrate in closed limits an odd function, you are going to get the integral to be equal to 0. So this integral also drops down to 0. So what do we remain with? This is what we remain with. You come and remain with integral from negative L to L f of x sin of n pi x over L dx equals to bn integral from negative L to L. If you multiply sin n pi x over L times sin n pi x over L, you are going to get sin squared n pi x over L dx. So this one from calculus identity, you recall sin squared of x equals to a half into 1 minus cos 2x. And in our case, it is sin squared n pi x over L, which will be equal to a half into 1 minus cos 2 n pi x over L. So this one is easier for us to integrate. That that one is easier for us to integrate. So which implies that Bn integral from negative L to L of sine squared n pi x over L dx equals to what? Equals to the integral from negative L to L of, that is a half into 1 minus equals 2 n pi x over L. So this one is, the integral is very simple. So it is going to be, there is a Bn here. So it is Bn divided by 2, and then we're integrating from negative L to L 1 dx minus Bn over 2 integral from negative L to L cos n pi x over L dx. So we proceed on with the integral. So it will be Bn all over 2, that is x from negative L to L minus, if you integrate cos n pi x over L, you get sine. So it will be Bn over 2 times L all over n pi, and then get sine n pi x over L, and the limits are from negative L to L. So if you substitute L in x here, it will be Bn over 2 into L minus L, you get plus L, and then minus Bn over 2 times L all over n pi. If you substitute L here in x, the L in x will cancel with the L in the denominator. So that will remain with sine n pi minus, if you substitute negative L in x here, it will also do what? Cancel with the L in the denominator. So sine n pi, it's a negative. So sine n pi with a negative. But remember, like I said, sine of n pi is always equal to 0. So as you can see here, everything else here will drop down to 0. And this is what we remain with. This is what we remain with. This is what we remain with. So we come and remain with Bn over 2 into L plus L. So L plus L is 2L. So the 2 in the numerator cancels with the 2 in the denominator. So that will come and remain with Bn times L. And that one is equals to the integral from negative L to L of f of x sine n pi x over L with respect to x. We want the coefficient Bn. So what do? We divide both sides by L. We divide both sides by L. We divide both sides by L. So which implies that Bn equals to 1 over L integral from negative L to L f of x sine of n pi x over L dx. So that is the general formula for finding the coefficient Bn. Thank you for watching, and please subscribe to this channel.